Okay, so this is note 17, multiplication of radicals. So yesterday we talked about adding and subtracting radicals. And when we were adding or subtracting them, we wanted to make sure we had the same radical. So that means the same radical with the same nth root. So they both had to be cube root, both had to be fourth root. On top of that, inside of the radical had to be the same number in order to combine them. So we'll notice for multiplication, we don't care if it's the same on the inside, okay? Because we're multiplying. So we're going to learn a different rule for multiplying radicals together. So the first thing we're going to talk about is the multiplication property. Then we're going to talk about expressions of the form the nth root of AB. Some special cases, and then how to multiply if we have different indices. And these indices, that's another fancy word for the nth root. So let's say if we're multiplying a square root with a cube root. Okay, they have different indices. Those are different nth root values. Okay. So the first concept is the property of multiplication. It says, let A and B represent real numbers such that the nth root of A and the nth root of B are both real. Then the nth root of A times B is the same as, okay, we can separate them and give them each their own radical. All this is telling us is if we're going to go multiply two radicals together, as long as they have the same nth root, we multiply the insides together. Okay, so for example, if this was the square root of 2 times the square root of 5, they're both square roots. So we multiply 2 times 5 and we get 10. So this is the square root of 10. So we multiply the numbers on the inside. Completely different than adding and subtracting, because we couldn't do that before. We had to make sure that they were exactly the same in order to add the coefficients in the front. Okay, this one, we don't mind. We can multiply them together. We're just going to have to simplify at the end, and we're going to do those in the next example. Okay. So this is the first example here. Notice we have both of them as square roots. Okay, that means we're able to multiply. They're both exactly the same root. We then just need to identify what is the radical and what is the coefficient. So we see coefficient 3 and 5, and radical, or square root of 2, square root of 6. That means that only the numbers that are similar, like the coefficients or the radicals, are the numbers we're multiplying together. Okay, so for example, this means we take 3 times 5. That's going to stay on the outside. And then we do the square root of 2 times 6. Okay, that is going to go inside the radical since originally they were inside the radical. So I can simplify this to 15 square roots of 12. Okay. But before I say, okay, this is my answer, I need to make sure my radical is as simplified as possible. And I check that by the prime factor tree, the same that we were doing yesterday. Okay, so I'm going to do the prime factor tree for 12. And so I get 2 and 6. What would be next off of 6?
3 and 2.
Good, 3 and 2 or 2 and 3. And since this is the square root, I'm going to circle a group of 2. And that group of 2 is going to come where? To the outside. And what's going to stay inside? The 3, right? The group that we circle goes on the outside. So that means we have 15 times 2, because we always multiply whatever's on the outside, and then the square root of 3, which means my answer is 30 square roots of 3.
So you don't do nothing to the outside number?
No, nothing to the outside number. Mm-mm.
Why didn't we include the 6, even though it's kind of like in the middle?
Why did we include the 6? You mean like
Like, why didn't we, the 6 on the,
oh, this right here? Because it's not prime.
oh.
We only care about the prime numbers. So that's why we include 3, because 3 is prime. Okay. Any other questions on the first one? Okay. Yes, these are primes. That's why we only look at these 3 numbers, because they're all prime. We ignore the 6 because it's not prime.
If it was, would we multiply it with the other one?
Correct. If 6 was prime and it was left over, we would take that number and multiply it by the other number that's left over, and that would stay on the inside. Okay, so now notice we have a variable also on the outside, and we have 2 variables under a radical. We're still going to do the same thing. We're going to identify, well, these are the coefficients on the outside, so I can multiply those together. So what's 2 times negative 7? Or sorry, 2x times negative 7. Negative 14x. Okay. Then I'm taking my radicals, and they're both square roots, so that's good. And then I'm going to multiply those together, which means I'm combining them under one radical. So what would I have? Xy squared, because I have y times x times y, which means I have 2 y's being multiplied, which gives me y squared, and then I have that x. Okay, same as before, though, I have to see if this can simplify. So I know right away the x can't come out, right? Because this is the square root, and I need to be able to circle a group of 2. So there's only one of those x's, but how many y's are there? 2. So if I write the 2 y's, that means I can circle them and take them out. So are the y's still inside the radical? No, they're outside. So I have negative 14xy square root of x. That is my answer. So for these ones, your final step is always going to see if you can simplify. Okay? That doesn't mean we will always have to simplify, okay? Because we could get to the radical and notice, well, there's nothing we can do, so we just leave it. Okay. Okay, so notice now we no longer have square root, we have cube root, but are they both cube root? Yes, that means we can continue. So 15c is on the outside of my first one, and 1/3 is on the outside of my next one. So what am I going to do with those 2 numbers? Multiply. So what's 15c times 1/3? 5, and then we can't forget that variable. 5c. 5c. So 15 times 1/3 is the same as saying 15 divided by 3. So that gave us 5c. Okay. We know now that everything under both of those radicals are going to combine to be under one radical. So we have a c in each one. So that's going to become what under the radical? C squared. And then I have 1d and then d squared. So that's going to become d cubed. Okay. Then I have to look at those variables and think, okay, can I simplify any of them? The d. And why can't I simplify c?
There's not enough.
There's not enough. There's only 2 of them and we needed 3. But d, how many do we have? 3. So if I was to write d 3 times, I could circle my group of 3, which tells me it's coming outside, and is anything staying inside? With good, just the c squared. So I have 5cd times the cube root of c squared, and that would be my answer.
Where's the D to the outside? Oh, never mind.
Because you see how we took it, there was 3 of them on the inside. Since the cube root, we could take all 3 out, which means we write that as 1D on the outside. Even write that here. Okay. Okay, so now we have something a little different here. Okay, notice that it's not just 2 radicals being multiplied. We have a 2 plus in the other parentheses. So what we're doing here is we're going to distribute the 3 square roots of 11. Okay, so I'm going to multiply that by the 2, and then I'm going to multiply that by square root of 11.
Is this because there's only a plus sign? Or because
It's because that second parenthesis has more than just a radical. It also has 2 plus. Versus the other ones, do you see how, notice that it was just a radical being multiplied, another radical being multiplied.
Right.
Versus this one has a radical being multiplied, but then this one has a radical plus something. Okay, so if you see, yeah, you could think of it that way. If you see the plus or minus in there, you know there's more than one step, so you have to distribute it in. And all that means is we're multiplying that 3 square root of 11 by every term. Okay. So what I'm going to do first is I'm going to write it out. So I have 3 square roots of 11 times 2. That's the first arrow. And then the next one is 3 square roots of 11 times the square root of 11. Okay, so this is what it would look like after we distribute that in. Okay. So what we're going to do is we're only going to combine the ones that are in common. So for example, this 3 and this 2 are coefficients. So we can multiply them. 3 times 2 is 6. And then we bring down the square root of 11. Because in this little spot here, there is not another radical for it to be multiplied by. Okay. And then the next part, we have the square root of 11 times the square root of 11. So there's 2 ways to think of this. We could combine it by doing 11 times 11, right? Or we could say, well, how many square roots of 11 are there? 2. So that's the same as saying 3 square roots of 11 squared. Okay, that's the same as like if we had x times x, we know that's x squared. Well, square root of 11 times square root of 11 is square root of 11 squared. And what we're going to see in a minute is that square is going to cancel with the square root. Okay, because technically, what's the in value above a square root? 2. There's technically a 2 right there. And since these values are the same, they cancel. Which means we're only left with 11 here. So we have 6 square roots of 11 plus 3 times 11. And then we just simplify 3 times 11 to be 33. 3 times 11?
Oh, sorry.
Yeah. You're probably thinking 6 times 3?
Yeah.
Yeah. Okay, 6 times the square root of 11 plus 33. Okay, this is our answer because I cannot combine it. Okay, I'm adding at this point, and I can only add those coefficients in the front if they both had the square root of 11.
So that's no longer a coefficient, basically?
It's a constant, correct? Yes.
You can't simplify the 6 square roots of 11 further?
Correct, we can't because 11 is prime.
Oh, okay.
So if it's prime, that means we can't think of any number that can divide into 11 besides 11. Okay. The other way that I was talking about, let's say you want to just use the rules that we're using in this notes, and we know that if we have 2 square roots, we can multiply the insides. Well, 11 times 11 is 121. So this is the same as saying the square root of 121 which is 11. Okay, so either way, you're going to get that answer of 11. So you either multiply them and then take the square root, or you know that the square root and the square cancel each other out, and you're just going to be left with whatever number is on the inside. Okay. Okay, so what's different about these two parentheses versus our last example? Good, both parentheses have a plus and a minus, which means we're no longer distributing. We're using what method?
Subdivision and subtraction.
No. FOIL method. Remember doing that in the beginning when we were factoring? Okay, so the FOIL method, if you recall, you take the first number and you multiply it in. And then you take the second number and multiply it in. So another word for FOIL is double distribution because we're distributing twice. So what I'm going to do is I'm going to write it all out first, just like we did, and then we'll go back and simplify. So my first arrow says square root of 5 times 2 square root of 5. Well, I'm going to write that just all next to each other, and we'll go back and simplify in the next step. The next red arrow is the square root of 5 times negative square root of 2. Okay, so this is plus square root of 5 times negative square root of 2. Okay. Now I'm looking at the first green arrow. I have 3 square roots of 2 times 2 square roots of 5. Okay, so I'm just going to write that exactly how I said. Okay, and then the last green arrow says 3 square roots of 2 times negative square roots of 2. So this is, I'm going to go on the next line, plus 3 square roots of 2 times negative square roots of 2. Okay, so now I can go back and simplify based off my properties of multiplication. Well, for starters, we know that we can rewrite this how?
25. But wouldn't that be just 5?
So you guys are saying both true things. You could write that as 2 times the square root of 25 because you did 5 times 5, which we know is 5. Or you could write this as with the parentheses squared, and we know that a square and a square root cancel out, so we are just left with 2 times 5. And I'm going to do that on the next step so I can do it step by step. Okay, on the next one, square root of 5 times negative square root of 2 is going to be negative square root of 10. Okay, the next one where it says 3 square roots of 2 and 2 square roots of 5, I'm first going to multiply the coefficients, which are 3 and 2, so that gives me, multiplying them, 6, and then I take the square root of 2 times the square root of 5, and I get the square root of 10. Okay, now I'm on this bottom one right here. So I have the 3 square roots of 2 times negative square roots of 2. So this is going to be negative 3
2 square root of 2 to the square?
Yes, square root of 2 squared, because there's 2 of them. Okay, now I can go back and I know that the square root squared cancels. So I'm going to make sure, okay, well that canceled and I know that canceled. Which means I just have numbers that I'm multiplying together. So 2 times 5 is 10. Okay, and then over here I have negative 3 times 2, which is negative 6. Okay, I just simplified those 2 on either ends. The radicals that are in the middle, okay, I need to see if I can simplify them. Because 10 is not prime. I can divide more numbers into 10. So I'm going to do 2 goes into 10 how many times? 5 times. Can I continue off of 5? No, because 5 is prime, which means I can't simplify the square root of 10. Because the square root of 10 is only 2 times 5, which is 2 prime numbers. So that means this is going to stay the square root of 10. So I can write myself a little note. Can't simplify. Because they're both prime numbers. So, which means I have 10 minus the square root of 10 plus 6 square root of 10 minus 6. So at this point, I'm just combining like terms. I'm able to combine the 10 and the negative 6 because they're just constants. And I get what? 4 or negative 4? Just 4, right? 10 minus 6. So I get 4. And then for the other ones, why am I able to combine these?
The same radical.
The same radical. They both have square root of 10, which means I just add or subtract the coefficients. So what's negative 1 plus 6? 5. So I have plus 5 square roots of 10. And that's my answer.
How come we don't get rid of the 10 though? Because in the other problems we added or subtracted them. And why doesn't this one cancel out?
You mean like why did this not cancel out like this one did?
Yeah, no, not like that. But like, isn't that technically like a negative radical 10 and a positive radical 10 or no?
Well, yes, but this is negative 1 radical 10, so this is only one negative 1. This is 6 positive ones. Because it's on the outside. So this is saying like if you have 6 of something and you just take away 1 of it, you still have 5 of that radical.
Okay.
It's a little different with multiplication versus the addition. Okay, and when we get to the answer of 4 plus 5 square roots of 10, we can't combine those because the 4 doesn't have a radical. Okay, so that's as simplified as we can get. Okay. So the next couple are going to be that same thing where we're going to have to FOIL and then simplify after we multiply. Okay, so starting with the top, I'm going to multiply the negative 10a square roots of b. And then the bottom, I'm going to multiply in the 7b. Okay. So I have negative 10a square roots of b times a square roots of b. Okay. Then I have negative 10 a square roots of b times 2b. So that's all the red arrows. I took that negative 10a square roots of b and I gave it to both terms in the second parenthesis. Okay. Now I'm going to do the green arrows, which I'm multiplying 7b. So this is plus 7b times a square roots of b, and then plus 7b times 2b. Okay, so once you get the hang of it, you won't have to write this step, right? You could, when you get better and you do more practice of this, you'll be able to simplify each radical before you write it down, okay? Because I could say, technically, instead of writing all this, I could say, well, this is negative 10a times a, which is negative 10a squared, and this is square root of b times square root of b, which is square root of b squared. Okay, so that's what I'm doing in that next step, is I'm just simplifying everything that I wrote. Okay, so that's the next part. And then now looking at this one here, how could I simplify that? Does the 2b have a radical? No, so that means I'm only going to be multiplying the coefficients. So I'm going to have what on the outside? Negative 20, and then what else? AB. Okay, so I'm going to have negative 20 AB times the square root of b, because only that one had a radical. Okay, what about this one? How would I simplify this? (7ab square root of b). So we're not simplifying as in trying to make the radical smaller. We're just making sure that we have all of the coefficients written together. Okay. And then the last one, how would I simplify this? 14b squared. So plus 14b squared. Okay. Then I can go through and I can see, okay, do I have any radicals that are being squared? Which means, can I cancel those out? Yes, I have this square root and this square, which means I just have b. Okay. So then what it looks like I have is I have negative 10a squared b, okay, plus 14b squared. Okay, notice I didn't combine these because they don't have the exact same variables. Okay, so I have to just leave them as is. Then on the next part, I'm looking at this and I'm seeing, can I simplify this? Yes, and there's two reasons why I can simplify this. What's the first reason? They have the same variables. They're both a, b on the outside. And what else? They both have, good, the same square root of b. Because remember, now we're adding. We're not multiplying, so they have to be the same. So that means this is going to simplify to negative 13ab square roots of b. And at this point, this is my answer. I'm not going to be able to simplify any further.
So for the answer, most of the time we're just going to give them a quick one.
Yes. Yes. Until we get to solving. So you know you're going to get a numerical answer if you have an equal sign in there. Okay. So the only other thing I could think of, because I know Alex is a little picky, right, is if they would want you to then take out a GCF. So if we were to take out a GCF from here, we could take out one thing, and what would that be?
B.
A B, right? And if we took out a B, we need to make sure we write everything that's left once we take out a B. That's only if Alex says, okay, you simplify more, right? For the most part, it should just accept answers like this. Okay. Okay. Okay, so now looking at this one, what's different?
Different radical.
You
Oh.
got two radicals in there. Parentheses.
Good, we have two radicals in one parenthesis. And what do we notice about that second parenthesis?
There's a 6 minus.
Yeah, so it's a little longer, okay? Which means when we're foiling, not only are we going to have to FOIL 2 times to each term, now we're foiling 3 times to each term. Because remember, the definition of FOIL is giving that first term and then giving it to every term inside. Okay, so we're still doing foiling. We just have 2 more extra steps. Okay, so the first thing is I'm going to multiply 2 square roots of x in. Do you guys want me to write it step by step again or try to say it verbally? Anyone else? Try to do it verbally? We can always go back and write it if we need to. Okay, so we have 2 square roots of x times 6. What would that give us? 12 what? 12 square roots of x.
Is that how you correctly say 12 square roots of x?
Yes, 12 square roots. And if it was cube root, 12 cube root of x. Any other number is just, it'd be like 12 times the 4th root of, 12 times the 5th root of. It's a mouthful.
Yes.
Yeah. Okay, so the next one is 2 square roots of 2 times negative, square roots of x times negative square roots of x.
So negative.
Negative 2.
X.
2 negative square root.
Oh,
Of x squared?
Negative.
Which simplifies to what?
Negative 2x.
Negative 2x. Does everyone see how?
Yes, because we're gonna skip that. We're gonna skip the.
Yeah,
square root,
because the
square root,
2's cancel out, right?
square root.
If you want to skip it, right? We're testing our knowledge right now,
Yes,
right?
I see.
Okay,
You
so
can skip it because it's gonna be more work than anything.
well, also remember the idea is the better we get, the faster you're able to answer more questions. Okay? And I can guarantee you college algebra is not going to just have 18 questions on a test. Right? You've got to be able to answer it faster. So we're training our brains here. Okay. Now we do the same 2 square roots of x times 8 square roots of y. What would that be?
16 xy squared times 2 square of the square root of xy.
Yes, so 2 times 8, 16. X times y, xy stays under the square root. So that is plus 16 square roots of xy. So we did all the red arrows. And yes, it is a lot less work for us to write if we do it this way. The only bad thing is if you make a mistake, right? Since we did it all verbally, we have nothing to look back at. That's the only downfall. Okay, so the next one we have the square root of y times 6.
6 square roots of y.
6 square roots of y. Okay. Then we have the square root of y times negative square root of x.
Negative square root of xy.
Negative square root xy. Okay, then last we have square root of y times 8 square root of y,
8 square root of y squared.
which simplifies to
8y.
8y. So the answer was 8 square roots of y squared, which simplifies to 8y. Okay, so now that we did this, we still have to go and see if we can combine any like terms. Like we're not eliminating all the steps by doing that mentally, right? We still got to go back and simplify more. So first I would go through and see if I have anything with like terms. So notice I have, okay, square root of just x. Do I have any more that are square root of just x?
No.
Nope. So then I check the next. This has a 2 and an x. Do I have another with just a variable x? No. Then I check this one. This is the square root of xy. Do I have anything similar?
Yes.
Yeah, so I know I'm going to be combining it with that. And then looking at the last two, can I combine 6 square root of y and 8y?
No.
No, they're different, right? One is just y and one is the square root of y. So that means my answer here is going to be 12 square root of x minus 2x. And if I was to combine the two that I highlighted blue, what would that be? 15 square root of xy plus 6 square root of y plus 8y. This whole thing is my answer. Because there's nothing I can combine them with, so there's nothing else I can do.
Are we allowed to use highlighters on the test?
Yeah. Mhm.
What is the purpose of this? Curious. How is this applicable?
Well,
Theoretically, it's applicable.
okay, so train your brain, right? Train your brain. But really, why is it important? I can't think of anything application-wise, but maybe, like if you're going to go up to calculus.
Is this like
Right?
a beginning step, like a mental step that we have to do get over, basically, to work quicker in certain models?
Yes, because when you move up to higher math classes, this part is going to be trivial. You know what I'm trying to say. It's going to be such a little thing that when your professor is doing the notes, there might not even show any of these steps. They're just going to go from point A to point B. Because the idea in the upper classes is, okay, I'm teaching you new concepts for this course,
Right.
which means you should retain the knowledge of previous math courses. So I'm sure there is some application. I just can't think of one on the top of my head. But it's more of we're building our skills.
Like compartmentalize. When you're making it like a little compartment in your brain.
Yes. It's like you don't want to forget about it. You're going to come back and use this, but you're never going to have like something where it says, okay, you need to foil this right now for your job, right? You're not going to be like, okay, you're going to have to, unless you're going to be a teacher.
Life or death.
Yeah, it's never going to be like, you need to remember how to foil this. No, you should know that if you see radicals, you know how to multiply them. You know how to add them, okay, in those instances. So yeah, just skills. I would think of this whole course as just skills that are going, not necessarily things that you're going to use in real life, but skills that will help you in your other courses. Okay, so the next concept we kind of already mentioned, and that is if we have a nth root that is going to be raised to the same exponent, we know that the radical and the exponent are going to what?
Yes.
Cancel. So this is the same as saying like an nth root of 2. These cancel, which means our answer is 11. Okay. Notice here, we have the same exact nth root with our exponent, so that tells us it's going to cancel, and what's our answer? Z. Brain break, right? Okay, so what would be the answer to this one? PQ, because we cancel out the cube and the cube root, and we're just left with what's inside, which is PQ. Okay, so any questions on this skill? Okay. Now we have special cases. Okay, and all that means is, special cases are more rules. If you want to remember every little single rule that makes your life easier, then you remember or memorize the special case. But you don't need to memorize the special case because we can do the same thing over and over again, and that's foiling. And we're going to get the same answer every time. So for this example here, this special case is that instead of writing 2 parentheses, they squared it. So all you need to know here is that this tells us to write the parentheses twice. Okay, what if it was a 3?
3 times.
You would write it 3 times. So here we're just writing the square root of d plus 3 2 times. And then once we see it written twice, we know we're going to have to FOIL. Multiply the double distribution. So first I'm multiplying the square root of d, and then I'm multiplying 3. Okay, after doing those hard ones, these ones are like piece of cake, right? So we have square root of d times the square root of d, which is d. Okay, square root of d times 3.
3 square root of d.
3 square root of d. Now we're on the green arrows, and that's a d, not an a. D. Okay, 3 square roots of d. Oh, I gave you the answer. 3 times the square roots of d. 3 square roots of d. And then lastly, 3 times 3. 9. Okay, so another reason this is a special case is because the only thing that you're going to be able to simplify is always adding those 2 middle terms. Okay, that's what you're always going to simplify. So if we're adding those 2 terms, since they're both the square root of d, we get what?
6.
Good. So D plus 6 square roots of D plus 9. That is our answer.
It doesn't become like D squared.
Well, the square root of, so this, the square root of D times the square root of D is the same as the square root of D squared. And the square root and the square cancel. So that's why we're just left with D.
Oh.
Is the reason why when you add them together the same as when we do add, for instance, 4D plus 2D? For instance, it becomes 6D.
Is there a correlation?
Yes.
Yes, if you think of them as objects, we're adding objects together, right? That would be the only correlation. This is a similar object, so we can add them together. Just like if it was both x. Those are similar objects, we can add them together.
For instance, like if it wasn't 3 square root of D plus 3 square root of D, but if it was like 3 square root of D plus 4 square root of D, it'd be 7 square root of D still? Or is it just because they're both matching?
Oh, you mean if this was instead of this, if this was just a 4?
No, a 4 square root of D plus 4 square root of D.
Oh, yes, plus 4 square root of D. Yes. Then that's 7 square root of D.
Yes.
As long as these are the same, that's all that matters. Yeah. Mhm. Okay, so we have another one where it's a parentheses squared, so that tells us we're going to do what?
Write it twice.
Write it twice. We also have 2 radicals in here. Okay. And it's also the same thing being multiplied by itself. So we're going to notice a lot of these radicals canceling out the same way we did the square root of D times the square root of D. Okay, so foiling this together, starting with the 5 square roots of y, and then the negative square roots of 2. Okay. We're still fine doing this mentally?
Yes.
Okay. So 5 square roots of y times 5 square roots of y.
25
what?
Yep, 25y. Right? Because square root of y times square root of y is square root of y squared, which cancels and we're left with just y. So we have 25y. And then I have 5 square roots of y times negative square roots of 2.
Negative 5 square root of 2 what?
Correct. Negative 5, because those are the numbers on the outside, the coefficients, times the square root of 2y, because those are both the numbers under the radical. So we just multiply them together.
And then the next is just going to be back, right?
Yes, so the next one is technically the same thing, right? We have negative square root of 2 times 5 square root of y, and we know that our property of multiplication, the order doesn't matter, right? So we get the same thing, negative 5 square roots of 2y. And then the last one, we have negative square roots of 2 times negative square roots of 2, which is positive 2. And with this special case, we know we're only combining
Like terms.
the like terms, and they're always going to be where? In the middle. So what is negative 5 square roots of 2y minus 5 square roots of 2y?
10.
Negative
10 to
10.
y.
Negative 10 times square roots of 2y. I know it's a mouthful. So that's our answer. We can't simplify further because one is the square root, the other one is just a variable, and the other one is just a constant. Okay. Now, these are our other special cases. So, notice these two parentheses are almost exactly the same, besides what?
Plus and minus.
The plus and minus. Good. So if we look back at these ones, right, when we solved these, since they were both plus signs, we ended up with middle terms. Okay? Since one is positive and one is negative here, what do you think is going to happen with those middle terms?
They're gonna cancel.
They're gonna cancel.
They're going to cancel out. Okay, so we're going to see that happen here. So we're distributing the square root of 3 and then distributing the 2. And so we have the square root of 3 times the square root of 3, which is 3. Then the square root of 3 times negative 2. Negative 2 square roots of 3. Because remember, this one's a square root and this one's a coefficient. So we can't combine them. Okay, and then what about the next one? 2 times the square root of 3.
Positive 2 square root of 3.
Positive 2 square roots of 3. And then lastly, we have 2 times negative 2.
-4.
Negative 4. Okay, so if we were to try to combine the two middle terms, what would happen?
Would it cancel out the coefficient but keep the radical?
No, it would cancel everything. Because think of the radical like an object, right? If you have 2 of one object and someone takes those same 2 objects away, you have nothing left. Okay, so that means in this one, we are just left with 3 minus 4, which is -1. 3 minus 4.
I'm sorry.
I don't know why I thought it was going to cancel it out because it was 2 negatives, but then I forgot it canceled out.
Yeah, it's because we use that with that. Yeah, we use the negative in the middle one. Okay, so this would be an instance where we got a numerical answer. Okay, and that was only because the square roots canceled itself out and we got a number. Okay, so ultimately what we did here is we looked at the negative one. So let's say look at this parentheses. And what we did is we squared this and got 3. And then we squared this and got -4. Okay, so this is the special case where it can help you simplify your steps if you know all the rules. So since we knew something was going to cancel out, I could look at a problem like this, look at only the one with the minus sign, and square each one, and I would get my same answer without writing this extra step. Okay, so we're going to try that on the next one. And the reason is because look at the next one. It is a mess, right? We have fractions in there. We have so many radicals. But the one thing I want you to check is to make sure that this is the exact same parentheses and that the only difference is the plus and minus. Okay, everyone agrees the exact same 2. Okay, so that means by my trick, my special case, I'm going to ignore this. It's not going away. I'm just ignoring it. And I'm going to take this term here and square it. And then this term here and square it. Sorry, I don't want to include that negative in there. Because I want to bring the negative down. Right? I want to bring the negative down because what happens when we multiply those last 2 is we end up with a negative. Okay. So if we're doing that, if we're doing, bless you, 1/3 square root of s squared minus 3/4 square root of t squared, we know that we have to give that square to the coefficient as well. Okay. So we're going to have to square the 1/3. Okay, so 1/3 squared. And then what happens to the square root and the square for the s? It cancels out, so we're just left with s. So I'm going to write an s next to this. Okay, and same thing with the next one. I'm going to take the 3/4 and I'm going to make sure I square it because I have to give that exponent to everything. And then I know that the square root and the square are going to do what? Cancel, which means I only have what? T. That means the only thing I need to do here is simplify those fractions. So remember, if they're being squared, that means the numerator and the denominator are being squared. So on the first one, what would I have in the numerator? 1, and what's on the denominator? 9. So this is 1/9 s minus, what would that fraction be? Square it. 9 over 16 t. And that's my answer. Okay. We would get the exact same answer if we went through the entire process of FOILing. Okay, because we would find out that those two middle terms would cancel, and we only care about the first and the last term, and that's what these are. This is the first term, and this is the last term.
We can only do this with the negative bunch, correct?
Yes, they have to be the exact same parentheses. The only difference is the plus and minus, and you have to do it with this one because you have to remember to bring down that minus sign. And if you do it with this one, then you could make the mistake of bringing down the plus sign, which changes your answer.
Is there gonna be a case where it doesn't have either one of those, like on the test, like it's gonna be plus and plus?
Well, if that's the case, if they're both plus, right, then you can't use this trick. You have to use the FOIL method.
If it does do the FOIL method, do we have to like make sure they have a common denominator, or no, just straight up just multiply it into?
Just multiplying, because when you multiply fractions, you just multiply numerators with numerators, denominators with denominators. Only if you were adding. But for this, no. This one's good. Okay. Any questions so far? Any other questions so far? Okay. We have our last two right here. This is the last concept, and it's multiplying radicals with different indices. And remember, indices is the different nth roots. Okay, so for example, we have the cube root of 5 times the fourth root of 5. Well, since they have different roots, we can't simply say this is the 12th root of 25, right? We can't just multiply. What we're going to have to do is convert this into an exponent. Okay, so remember we did something like that on the notes where we went from radical to exponent, exponent to radical. So how would the cube root of 5 be written as an exponent? 5 to the...
Cube.
No, not cubed. No.
What was the question?
No. How do I turn the cube root of 5 into an exponent, making it 5 to what power?
Of the 1/3.
1/3, right? And how'd you get 1/3?
Because it's the, what do you call it? The root sign is the.
The nth root? It's the, okay, this nth root here is the denominator. Where'd the 1 come from?
The outside of the, it's supposed to be the
Squared
exponent.
one time.
So the radical would be 3 and the exponent would be 1.
1 over n.
Yes.
1 over n. Or
Y-
n. It would-
yes.
Something like that, right?
Is it because the exponent on the outside or m is supposed to be 1?
Yes, that's what they're trying to say. Yes, so technically there's a to the 1 power here, right? And that 1 power is what goes up here.
So you can just multiply those and just multiply like the 5, 1/3, multiply.
No, not quite. You can't. You have to go through this process first, and then we're going to go back and combine these using the properties of exponents. So, with that being said, how do we write the fourth root of 5? 1 over 4 power. Okay, so now that we read it like this, we have to then think about properties of exponents. Properties of exponents say if we have the same base and we're multiplying, what can we do to the exponents?
Add them together.
Add them together. So this is the same as saying 5 to the 1/3 plus 1/4. Okay, however, can I add them if they don't have a common denominator?
Maybe.
No. No. Remember, add or subtract, you cannot. You got to find a common denominator, so I'm going to do that over here. I have 1/3 and 1/4. What would be their common denominator? 12, which means I need to multiply the first fraction by 4. And the other one by 3. Top and bottom. Which means I get 4/12. And the other one? 3/12. So I go back to my problem, and this is now 5 to the 4/12 plus 3/12, which equals 5 to the 7/12. And now that I have it with one base and one exponent, I can now convert it back to a radical. And now it's combined as one radical. So how would I convert that to a radical?
Would it be n through 12? Yeah, 12 to the square root of 5, and the exponent be 7?
Correct. So you say the 12th root of 5 to the 7th power. Okay, because remember we said the denominator goes to the nth root and the numerator is the exponent. So this is taking a couple notes, putting it together. Okay, so it's not too bad like this, right? Because we have the same base. But we're going to make it a little harder, right? Because we want to challenge ourselves. And now we're going to have different bases.
So then, that one.
Would you just still multiply it, or you find a common thing?
So in order to simplify this, we need to get a common base. Okay, so that means they both, sorry, not a common base. We need to get a common nth root, right? So right now we have a cube root and a square root. So if we do the first step the same. We're going to convert this into exponential. So this is 7 to the 1/3 power times 2 to the 1/2 power. Well, if we want the same exact radical, that means we need to have the same exact base for our fractions. Okay, so we have 1/3 and 1/2. What's the common denominator? 6. So what are we multiplying the first fraction by? 2. And then the next fraction? 3. So what do we get for the first fraction? 2/6. And then the next fraction? 3/6, so I'm going to replace them. Okay, so now I have 7 to the 2/6 times 2 to the 3/6. Which means if I was to convert this back to radicals, we would have the same nth root. And that's what we want in order to multiply. So I'm going to convert this back. So how would I write 7 to the 2/6 power?
7 to the square root of 7 to the 6th power. No, this
Opposite, yep.
Yeah, the 6
square root.
outside.
The 6th root.
6th root of 7.
Uh-huh.
7 squared.
Squared. Where'd you get in the 5 from?
Oh, I added them together, my bad.
Oh, okay, yeah, 5. We can't add them together because they're different bases. So we got to turn them individually back to their corresponding radicals. So how would I change 2 to the 3/6 back?
6th root of 2 cubed.
Correct. Okay, so now that they're both the 6th root, I can use my property of multiplication, and I can do what with the insides? Multiply them. So this is now the 6th root of 7 squared times 2 cubed. And I got to figure out what that is, right? So what is 7 squared? 49. What is 2 cubed? 8, right? 2 times 2 is 4. 4 times 2 is 8. You're going to have to do this for me. I don't know what this is. 49 times 8.
392.
392. So then we have the 6th root of 392. And are we done?
No.
No, what do we got to try to do?
Simplify.
Simplify. Okay, and we simplify how?
Prime factorization.
prime factor tree, and we always try to start with 2. So you're going to have to help me out. What? 392 divided by 2.
196.
196. Okay, that divided by 2.
98.
98.
By 2.
Right, that divided by 2. 40 what? 49. Can I divide by 2? No, I can do 7 times 7. Okay, does this look familiar?
Yes.
What does it look like?
Yesterday.
No, not yesterday. It should look like, sorry, say again what you're saying in the back.
It's like the 7 square.
Uh-huh.
And the 2 looks like the 2 to
Correct. So look, we have 3 2s. That's 2 cubed. We have 2 7s. That's 7 squared. So what this tells me, for one, I didn't have to do all this. I could look at this and see, since I have 7 squared and 2 to the 3rd power, would I have enough of either of those to come out?
No.
No, why not?
Because none of them get to 6.
None of them get to 6. So this is 7 squared. 2 is smaller than 6. 2 cubed. 3 is smaller than 6. Which tells me, and I proved here with the factor tree, do I have any pairs of 6 that I can take out? No. So that means this is as simplified as possible. So my answer is just the 6th root of 392.